right, so 5.2 starts our discussion of multiplication and division of integers. So we're going to see these same models that we saw before, and we're going to do some multiplication and division with the models now instead of the addition and subtraction like we were doing in the last section. And so this first one we're going to do is we're going to jump right in. We're going to start with these models that we just finished working with. Okay, so they're fresh in your mind. We're going to take a look at the chip model. So these are the most awkward to do with the models. The addition and subtraction are much more natural, I'm not going to lie, but they still give a concrete basis for what we're doing, and that's what we're looking for here, okay? The concrete analogy of what's going on. All right, so to start with, the first number that we see listed here is a -4, correct? Whoops, that's not what I want to do. Draw with the arrow. All right, this -4, the negative tells us that we're going to remove something. And the 4 tells us we're going to remove 4 groups. Okay, so the negative means remove, the 4 means 4 groups. The second value tells us what the groups are going to look like. These are going to be groups of, in this case, 3 red chips. You guys obviously know that multiplication is commutative, so we could turn this around and then we could exactly say the exact opposite. We could say -3 means I'm going to remove 3 groups, and the -4 means of 4 red chips. Okay, so it doesn't really matter which one it is we go with. We're just going to pick one, and that's what we're doing. Okay. So we're going to draw our circle. And inside our circle, we need to have 4 groups of 3 red chips. Right? Otherwise, we can't remove them. So I need 4 groups of 3 red chips. So let me turn my thing red. So here's 1, 2, 3. There's one group of 3 red chips. 1, 2, 3. There's a second group of 3 red chips. Third group of 3 red chips. Fourth group of 3 red chips. So I've got 4 groups of 3 red chips. All good? Okay. Then what happens is that I'm going to draw my circles out and remove them. Now, when they remove out, this is where things are a little different than the addition and subtraction. When they remove out of here, well, maybe I should draw it. I'll stick with the way I've got it on here because I think that's what your book uses. I've seen a couple of different ways of doing this, but we'll stick with what I've got on here. When they come out into this other circle, I guess you'd say. And as they move out of the circle, they change signs. So it's almost like they're crossing, the edge of that circle. And in crossing the edge of that circle, their signs change. So if I were to remove something that was positive, it would become negative. If I remove something that's negative, it becomes positive. Yes?
Could you not just, like we did in subtraction, like pair each of the red with a black?
You can, and I think your book might actually show that as an option as well. So if we did that, it would look something like this. Let's take that model because that sounds like a really good approach. Okay, so Mary Lee, you had in mind that we started with our same. Oh, come on. Okay, describe what you would like me to do, Mary Lee. Let's just start there.
You would have the 12 red dots and you also have 12 black dots.
Okay, what do you want it to look like? Say again.
12 red dots, and then they're each paired with black dots. And then 12 red, 12 black.
So start with 0 in the circle.
Yes.
We could do that. Mm-hmm.
And the negative removes the red ones, and so you're left with
like that. That sounds good. So your negative is going to remove your groups of 4 red. Or, sorry, 4 groups of 3 reds, right? This is not working so well. Like so? And then you're left with the 12 black. That looks pretty good. Or 10, was it 12? Yeah, it was 12. 12 blacks. That looks pretty good. I've seen a model that does that. I'm not sure that your book does it quite that way, but I like that. What do you guys think? So you start out with nothing in your circle, and then you introduce the same things that you need to have in there. That is all of the black dots and all the red dots, and then remove the pieces that you would like to remove. That sounds good. Let's do that same. Yeah, sure. Let's go with it. I like that better than what your book does. So yeah, let's go with that model. If you're trying to interpret something that your book has already done, it's probably not going to work though, because they're going to have done something else differently. Let's use that approach and try for the chip model, or not the chip model, but the charged field model that follows with the same idea that Marilee had. Okay, so let's draw our circle. And inside of our circle, we have nothing right now. And we are going to introduce what? What do we need to have in our circle?
12 positives and 12 negatives.
All right, there's 12 positives, and then we're going to have 12 negatives to go along with those. Okay, so if I've got this going on, the circle currently has 0 in it, right? Okay, and then what I'm supposed to do is I'm supposed to remove 4 groups of 3 negatives. So we're going to group the 3 negatives, sorry, we're going to group the negatives in 3s and remove 4 times what we have. So I've got to group them in 3s. We'll do it like that. That one, and that one. So when we remove them, the result is a circle that has 12 positives in it, right? Yeah, that looks pretty good. What do you think? All right, any questions on that one? Okay. What part, Becca?
Why did we start, why did we write 12 of each this time instead of...
So that was what Marilee's suggestion was, and I think it's a pretty good one. So the idea being that the circle has nothing in it to start with. Okay, well, when I put the 12 pluses and the 12 minuses in there, it's still got nothing in it, because I've got the result in. The result would be as a result of 0. And then this is still telling me I need to remove 4 groups, and I need to remove the 4 groups of 3 negatives. So I've grouped them in groups of the negatives in groups of 3, and I've removed all 4 groups of 3. So when I remove that, then it leaves the 12 positives from the circle, which gives me the result of 12.
Okay.
Yep, Hannah?
Can't we just say that a negative times a negative is a positive?
You can say it to your heart's content, but what happens when a child asks you why? I don't know either. So this is what this is doing, right? It's giving you some of the ability to tell a child why. And so one of the idea of concrete models is the idea of letting kids discover that fact for themselves. So if you've already done this, you could actually now say, well, look what happened. We have -4 times -3. We've drawn this model and described it in this way, like we just did with Becca, describing that one more time there. And we can say, well, what was the result? Well, the result of doing this was I ended up with 12 positives in the circle, and the answer was 12. Well, look back at the original problem. It was -4 and -3, and the answer became 12. So what happened?
Well, then you just said the negatives cancel each other out.
Okay, so what do you mean by cancel?
You just take away the negative signs.
Okay, but why?
Because there's 2 of them.
Okay, well, if you say that, then you're going to have to justify why that works with multiplication and doesn't work with addition or subtraction. If just having 2 negatives removes something, that's sort of an arbitrary why.
With subtraction, we just learned to draw a plus sign over it. Like, we didn't learn any of this stuff.
I know, but you know what?
But none of us asked why.
That doesn't mean that nobody asked why. That means none of you guys asked why. There's a difference in there. You get your classroom and you're going to have 24-ish students. And you're going to have the one that asks you why. And you're going to, you're not going to go in the hallway, Hannah. So one of the real big things about this class, all three of the Math 1, 2, 3 classes, is giving you the ability, whether you're doing it on the spot or not, to be able to go back and answer the child later as to why. So this is a good example for the why in the world does it work out that a negative times a negative is a positive. There's the next model that I'm going to show you, the number line model, has that same feature to it. Okay, let me show you the number line model, and it'll be where we stop for today. And then we'll keep working on the next part of this afterwards. Next class period. All right, so when we do the number line model, the first one is the direction. We did this before, sort of identifying that pieces of this, my pen's just not going to work, pieces of this mean different things. So the first thing, the -4, is the direction. It tells us move left 4 at a time. And this one's the awkward one. This one tells you that the time starting three hours ago. I like the chip model better, just so you know, but I'm going to show you this one because your book shows it. Is it readable enough? Hands don't write very well. My stylus isn't working, so. All right, so you're going to draw your number line model. We know that we're supposed to end up with a positive 12 on this solution, correct? That -4 tells me I'm supposed to be making -4 leaps. So I'm supposed to be making a jump that's -4, but I'm supposed to be making it left. Okay? So I'm just going to draw these in here. I'm not going to draw in the number values for it, but I'm just going to arbitrarily put in 4 jumps. I'm sorry, jumps that are 4 left. So this one right here, this one right here, and this one right here. Each of those are 4 units long, and I'm moving left. So far, so good? I did it 3 times because I know I'm going to be doing it 3 times by the other value. The other value said 3 times I'm supposed to do this. So I end up at time 0, or I end up at location 0, I end up at the place I wanted to be. The question was, where did I start at? So where would I have had to have started if after 3 hours I end up back at 0? 12. So the answer is actually the starting place to the question. I feel like this one's very awkward, but it is the number line model for the equivalent here. So the idea of one of the numbers being moving left, the idea of the other number being negative amounts of time, that is in the past. Yes, Tina?
So why are we using time? Like, when did time come into play?
That's the convention that they're putting on. It's like, say, why do chips mean negative and positive? It's the convention that we've placed upon it. Yeah. They're using time to indicate in the past. So, and again, why is it hours? It didn't have to be hours, but we could use minutes. I mean, you could use whatever length of time you wanted to talk about. That's what they're sort of placing upon this model. Yeah. All right.